Hey everybody. Well, happy Monday afternoon or evening. It's actually still evening. It's actually evening time now, after 5. And tonight's homework, we only have 5 problems. We're doing numerical expressions slash order of operations. And remember, order of operations are the rules of which operations come first, what do we work with, and what comes last. Let's go ahead and get busy. So on this first question, during winter break, Michelle loved to bake sweets to give us sweets to give as gifts. So, looking at our bullets, this is what she did. She made 4 chocolate cakes and used 2 cups of sugar for each. All right. So, I'm you thinking about okay, she made 4 chocolate cakes and used 2 cups of sugar for each. The next one is she made 5 batches of candy. Okay, that's really very good. Each batch takes 3 cups of sugar. She also used 7 cups of sugar to make some pies. Which equation shows how to find T, the number of cups of sugar used in all? Okay, so T is going to represent number of sugar. So we could still have a question, how many cups of sugar does she use in all? We could have that, but in this one here, it's like, okay, so our answer is going to be labeled as T, number of cups she used in all. So let's come through here and let's think about this. I know that she had 4 chocolate cakes. So I'm going to kind of draw out, I put little candles on here, right? Looks like the flame. That's 1 chocolate cake. 2 chocolate cakes. It doesn't really look like a chocolate cake, but I'm going to make it work. 3. And 4. So I have my 4 chocolate cakes. It said that each one took 2 cups. 2C, 2 cups, 2 cups, 2 cups. All right, so based on this picture that I drew, which one over here will then work for that she had 4 cakes. Each cake took 2 cups of sugar to bake or to use because remember that we're having to find out how much sugar she used in all. Okay, so this is an addition problem, 4 plus 2, that doesn't make any sense, does it? So I'm going to cross that out. This seems like it makes some sense. I had 4 groups. Each group had 2 cups in each. 4 times 5. Nope, that's 4 cakes and 5 batches of candy. That doesn't make any sense. And 4 times 5, oops, I may find out what I'm looking for. So now let's go on. She had 5 batches of candy. Yep, so I'm going to just do 1 batch, 2 batch, 3 batch, 4 batch, 5 batch. This is candy. And for each batch of candy, she used 3 cups of sugar. So what would be my operation here to find out how many cups of sugar she used? Yeah, there we go. Look, 5 times 3. This is going to be my candy. Then it says she also used 7 cups of sugar to make some pies. So here's the used 7 cups. So which one is going to be the right expression? Absolutely right. It's B. Good job. So if you're drawing it out, and it really kind of helps out a lot better, as an understanding of what your story is talking about. Let's look at number 2. The principal at West Village Elementary wants to order agenda books for teacher and student. There are 536 students and 28 teachers at the school. So it's great. It's a good amount of students. It's a small school. The cost of agenda books is $8 each. Now we've run into that situation here when we get agenda books, but we don't charge. We used to, but we don't anymore. Which equation could be used to find T, the total cost of agenda books? So T is going to be total cost of the agenda books is what we're looking for. I know that there are 536 students, here's that magic word, and 28 teachers. Which one shows that we're going to have a combination? I have 536 and 28 teachers at school. Very good. This one has a plus sign, and this has a plus sign. I have to double check. And this has a plus sign. So I can get rid of B. And then it says that the cost of the agenda books is $8 each. Each, I know that I have to multiply. Well, if I keep it like this, remember order of operations means I'm only going to multiply the 28 times 8 and then add 536. That won't work out. So let's take a look. A looks like I put the parentheses. I have to take care of what's in that parentheses first, then multiply by 8. That looks like it's pretty good. Then the next one, 536 plus 28, then plus $8 to it. That doesn't make any sense. We have people and then money that we're adding, so that doesn't make sense. 536 plus 28, and I'm going to take that one and divide those into 8 equal parts. No, I'm not dividing anything. I'm trying to find the total cost. Total means that it's going to be increasing. So the right answer, or the correct one, numeric expression to match the story is A. Let's move to the number 3. Catherine had 554 stickers. So this is the total number of stickers she has. She used 20 stickers. She used 20 of the stickers to decorate a card for her to her grandma. Oh, that was nice. So she took her 154 stickers and used 20 of those. Which ones can I use right now? Okay, that won't make sense here. She didn't add to her total that she had. She took away, she took away. She had 154 total stickers, not 124. So this doesn't work out. So I'm going to cross this out, cross that out. Next, she used the remaining stickers to make 4 posters. But she used the same number of sheets to make each poster. So I've got to first find out how many stickers she has remaining, and then I need to separate those into my 4 groups. We use division to show that we are breaking those into how many in each group. So it's not going to be times 4 to make it bigger, but we are dividing. So the answer is B. Okay, look at number 4. Joseph is buying hot dogs for a party. Oh, sounds great. There will be 13 adults and 17 children at his party. Now he plans to make 3 hot dogs per adult and 1 hot dog per child. So now I'm going to have 13 adults. Each adult's going to receive 3 hot dogs. So how many would I need there? And there's 17 children. Each one's going to get 1. And then there's 8 hot dogs sold in each package. So I need to find out how many packages I need to purchase. So which equation would best fit to find P? the least number of packages of hot dogs Joseph will need in order to have enough hot dogs for his party. So if I do 13 times 3 plus, well, here what I see what they did is they just said plus 17, because what is 17 times 1? Absolutely, it's 17. So if I add those together and my 17 hot dogs, my 13 adults, 3 hot dogs each, plus the 17 for my children, and I divide those by 8, that pretty much makes sense. I'm going to take my 13 and I'm going to multiply it by 17. I'm taking my 13 adults and multiply that by 17 kids, and that doesn't make any sense there. I have my 13 plus 17. Okay, so looking at here, I got to do what's in parentheses first. So I added the kids, then I multiplied that by 8. And that was, there were 8 in the hot dog. Well, I could do that, but divide by 3 is each adult. I only have 13 adults, so this is per person, and that everyone was going to get 8 each, and then divide those by 3 because there's 3 in a package. No, that doesn't make any sense. Because it's, and then even if we wanted to say, oh, okay, well, if they were going to get 3 each, the kids aren't getting 3 each, they're only getting 1. So here I have 13 adults plus 17 times 3. Are the children eating 3 hot dogs each? No, it's the adults that are eating 3 hot dogs each. So this is going to be the best answer here. So we'll have 13 times 7 plus 17, and then it'll be divided by 8. All right. And the last one, Jacob wrote this expression, 10 divided by 5 plus 4. And remember that when there is not an operation and there's a number next to a parentheses, it means to multiply. So you'll do everything in the parentheses first, then you'll multiply that by 4. So let's look at this. What do these parentheses indicate in this expression? Oh my goodness. So what do those parentheses represent, or what do they mean? Does it mean to divide 10 by 5 before adding 4? No, not at all. Does it mean to multiply 4 by 72? No, because we have what we got to do in the parentheses first. So I underline the 72 minus 6. So that makes no sense. Am I going to add 5 and 4 together? No. No, that's not what we do. Am I going to subtract 6 from 72 before multiplying 4? And that is yes, that's what we'll do. And this is the work that we have for today. Please go and review if you're not understanding it so that you'll be ready for Friday's test. You do have a unit assessment on Friday that's going to cover 1 question on prime and composite, lots of questions on numerical expression on what we just covered, order of operations on what rules come first, and some multi-step problems on adding, subtracting, multiplying, dividing. Guys, have a great evening. Talk to you later.